Greetings and welcome to Talk a Little, Learn a Lot, the American Society of Naval Engineers podcast. I am your host, Stephen Phillips. In this podcast, we talk a little and learn a lot about naval engineering while inspiring the next generation of STEM professionals. Today, I'm joined by John Daidola, President and Technical Director of the AENY Naval Architects and Marine Engineers, to discuss his recent Naval Engineers Journal article on hull structure materials for naval vessels. John, thanks for joining me on the podcast. I look forward to this discussion.
Thanks, Stephen. It's my pleasure to be here to discuss my research and paper to be published in the Naval Engineering Journal.
John, let's start with, would you introduce yourself to the Talk a Little, Learn a Lot audience?
Sure. I'm a graduate of the University of Michigan and Stevens Institute of Technology in Naval Architecture and Marine Engineering, and a licensed engineer, having practiced for over 50 years and authoring in the order of 120 publications on a variety of subjects of interest to the maritime industry. Currently, as you've mentioned, I'm president and technical director of the Naval Architecture and Marine Engineering firm AENY, which was founded in 2006, and an adjunct professor at the U.S. Merchant Marine Academy in Kings Point, New York, in their graduate program. I've been employed by Newport News Shipbuilding, the Naval Architecture and Marine Engineering firm M. Rosenblatt and Son, and his successors, professor at Webb Institute of Naval Architecture, and owner of a boat builder. I'm a Life Fellow and Honorary Vice President of the Society of Naval Architects and Marine Engineers, or SNAME, its past functional Vice President, Technical, and Chair of its Technical and Research Program, also having received its highest award, the David W. Taylor Medal for Notable Achievement in Naval Architecture and Marine Engineering. I'm a longtime member of ASNE, as well as the Connecticut Maritime Association.
John, I always have to ask someone, when did you first realize that you had a passion or affinity for naval engineering?
Well, it was when I was young and taken fishing by my father on small boats. It all started then.
I think it starts that way for a lot of people. Do you have a favorite naval engineering sea story?
Sort of, but as an example of challenges we encounter as naval engineers, I would cite a time when during proposal review for a construction contract of an oceanographic ship being required to change the design to mount the entire large machinery system on a floating subbase in that ship that had already been designed and approved by a classification society with 3 weeks to complete and receive reapprovals. We did and won.
As we both said in the opening, we're here to discuss your Naval Engineers Journal that's coming up entitled Selection of Hull Structure Material for Naval Vessels. What was the inspiration to write and submit this piece to the NEJ?
Through the years, I've had the opportunity to work with different materials. And in 2017, I started to study using titanium for a large vessel under funding from the Office of Naval Research. I was encouraged to look at other materials by past projects funded by the U.S. Interagency Ship Structure Committee on applications of aluminum and glass reinforced plastic to ships. With rising costs of shipbuilding, I thought it important to continue investigating with self-funded research of my own.
What materials are typically used for shipbuilding?
Steel is exclusively the hull structural material for large ships. Small and medium-sized vessels have been constructed from wood, ferrocement, aluminum, and various fiber-reinforced plastics.
You know, when folks think about large ships, of course, they normally think about steel. What are the advantages of using steel for large ships?
Steel material is well known and supported by design criteria and production processes, readily available and relatively cheap. There are labor resources knowledgeable in its construction, and it has been very successful for more than a century. A more comprehensive list is in the paper.
What are the pros and cons for using aluminum?
Aluminum material is lighter than steel, has corrosion resistance with care, also supported with design criteria and known production processes, and a labor force with experience. It is more costly as a material. A more comprehensive list is in the paper.
And when would one employ fiber reinforced plastic or fiberglass?
They have been utilized for boats and even minesweepers and hunters, but not large ships. There was a past study under the Ship Structure Committee on utilizing and producing tankers and bulk carriers from fiberglass or GRP.
You know, in a previous episode, we discussed employing titanium for submersibles. What other applications are there for this material?
Titanium has been utilized in ships for some machinery system components as a consequence of its anti-corrosive nature and strength. Nevertheless, it is about half the weight of steel, which is good for ships as they float. The Russians built the largest class of submarines in titanium, but it has otherwise been relegated to a few smaller craft. The U.S. Navy did consider it for the T-craft years ago, and a small section of that vessel was built in both titanium and aluminum for comparison. This effort also served as a study to improve welding and manufacturing procedures for titanium.
I think some in the audience might be surprised that ferro cement is used for hull construction. What is ferro cement and what are the advantages of this material?
Ferrocement is a concrete base with steel reinforcement. It is the lowest cost of materials, is readily available, and requires the least skilled labor. Accordingly, it is used around the world for smaller vessels.
You have considered alternative production of hull structures. What influence considering these alternatives and what have you discovered?
The construction of alternative materials has essentially been for smaller craft and is generally affected by the experience of the designer and builder. The greater cost of the material itself is often cited as a reason not to utilize, but this ignores that these materials do not affect the ship cost in the same proportion, as the structure is only one component of the cost of the entire vessel. It will be diluted by the costs of machinery, outfit, command and control, and so on. At the same time, these materials can extend the life of the ship and improve payload and cargo carrying ability, which can result in the vessel having the same utility for more than one ship constructed of steel. This is, in fact, what I found.
Yeah, indeed. Can you describe to the audience your method for comparing the different materials for hulls?
As a consequence of the previous question, the method has centered on determining the number of steel ships, termed equivalent steel vessels or ESVs, which a ship of another hull structural material could replace. The variables used to determine the ESVs are the projected years of service, payload, fuel consumption, maintenance, vessel size, and cost. This is intended to reflect the potential savings, not to necessarily reduce the number of ships, which would be dependent on the service the ships would be required to provide. It does support increasing the number of ships by utilizing the indicated savings.
And does this also take into account everything that might occur during the life of a ship? Like, all right, it's operating in rough seas, it's conducting flight operations, it has to go through so many dry docking evolutions.
A ship constructed of alternative materials will also need to be designed to meet these requirements, and there is no reason to believe it cannot be. Of course, of greater significance is that there is little to none experience in building large ships with these materials, and the design codes available are mostly for steel. There will be a need to develop both design material and production processes.
And so, should we now consider building larger ships with something other than steel?
I believe it is in our interest to continue investigating this matter to improve our understanding of the potential. This can include more detailed evaluation of specific vessels, development of design criteria, and production processes and their elements, as would be required for these alternate materials.
Are there other materials that have been considered or tried for in shipbuilding that we should mention?
I believe the list I addressed is complete.
Okay. Well, John, what are you working on next?
As mentioned in my bio, I have sought to investigate areas in which there is interest, or at least I believe deserve some attention. I've enjoyed doing this and intend to continue. I do have another paper presentation coming up entitled U.S. Short Sea Shipping and Greenhouse Gas Reduction Opportunities.
John, what ASNE events have you participated in over the years?
Over the years, I've attended many ASNE events and was the chair of its metropolitan section in the greater New York area for more than a decade. More recently, I attended the MAC and presented last year and will be presenting the subject paper at FMMS 25 in San Diego.
Have you written for the Naval Engineers Journal before?
Yes, in 2017, 20, and 22 on the subject of hull structure, and 2021 on ship maneuverability.
So, being a longtime ASNE member, are there any changes that you would like to see for the organization?
All I can say is keep up the good work and service to our industry.
John, this is another question I ask folks. So, what do you think are the key challenges that naval engineering is facing today?
For one that relates to the subject at hand, the shipbuilding status in the U.S. has recently been under scrutiny, as well as the number of naval vessels being delivered compared to some other nations. The cost of building ships in the U.S. is much more than in other major shipbuilding countries. With our skilled labor, the utilization of higher tech material, such as being discussed here, may be a positive contribution.
John, this is a similar question. Where do you see opportunities for investment in naval engineering?
Uh, I'm going to stick to the topic, Stephen. I've just mentioned the potential opportunity to use alternative materials. A successful investment in confirming benefit and possibility would be like what happened in the smaller vessel industry in the 1950s and 60s, where, as I said for steel now, wood was the exclusive material. It has since essentially been displaced by the same alternative materials I have discussed.
John, is there anything else that you would like to share with the ASNE audience?
Yes, I would regarding professional societies like ASNE. They have been continuing to face lower levels of participation by the same individuals, companies, and governments that they serve. In my years in the industry, being involved member has not only been and continues to be rewarding, it helped me achieve all along the way. One significant difference from when I started and now is that many of the industry leaders are no longer participating themselves, nor encouraging and supporting their employees. In my opinion, we all need to collectively and individually support these organizations. Without them, our productivity and experiences will be less.
Yeah, indeed. Well, thank you then, John Daidola, for taking this time to discuss hull structure material for naval vessels and a little bit of your thoughts on ASNE, the future, and the state of naval engineering. I hope that we can welcome you back again to Talk a Little, Learn a Lot, the podcast of the American Society of Naval Engineers.
Well, thank you, Stephen. I've enjoyed it very much and would be very happy to come back another time if I have something that would be of interest to your audience.